This conference will now be recorded.
Okay, welcome to this lecture. As we know that while developing the keying model, understanding the notations and assumptions of it is imperative. And therefore, today in this lecture, we are going to discuss in detail what are important notations and assumptions laid down regarding the keying model. And therefore, today we discuss one by one the notations and assumptions of keying model. In this way, you are getting my voice?
Yes, sir. Yes, sir.
So in this lecture, this is very important because we have to deal with the in-depth derivations, the applications, the mathematical discussions, analytical discussions. But the basic idea behind this, how we represent, how we have the notations, how the assumptions are important while developing the keying model is an essential aspect of discussion of the keying model. So therefore, we remember here D.C. Kendall, his duration of the life, 1918 to 2007. He was basically mathematician, English mathematician, and a statistician who was working in the University of Oxford. And his area of interest, his areas of interest include probability theory and keying theory and others. So this development of the notations of the keying models, this credit the primary development of the notations of the keying model. This credit goes to Professor D.G. Kendall. So it is very popularly known by the name of Kendall and popularly known as Kendall's notation. So if you search in your literature the Kendall's notation, immediately you will find the Kendall notations. What is the Kendall notations? If we look at Kendall notation, he gave this kind of notations. There are 6 letters here. These 6 letters are A, B, C, D, E, and F. These notations says the first A. What does it mean by first A? This is the oblique. This is after one letter. There will be a oblique, another oblique, so forth, so on, up to E. The oblique symbol must be put here, and F is the last. It is without oblique. A is what? We have to mention here A is arrival like Poisson or exponential, whatever we say. And this is represented by M. M is what? M is here Markovian. Why Markovian? We will discuss in detail at the appropriate point of the time when we are going to discuss the keying model, any particular keying model. First, we will discuss the general keying model having the Poisson distribution, and later we will start discussing the particular keying models. So in that very case, we will discuss this very point that why this M, though this is represented and actualized, the situation of the arrival is actualized by the Poisson distribution or the exponential distribution. But it is always in the literature represented by M. And M means you may have known it. This is Markovian. So B is what? B is service. For service, Poisson and exponential. We simply write the again M means Markovian. C is number of servers. You look at here. This is C. This is C. C is what? Number of servers. How many number of servers are engaged in the channel who are providing the service to the customers? That number of servers may be single, maybe double, triple, so forth, so on. So this number of server is represented at third place here. And the fourth is D. D, it is perchance D is representing the discipline, like first come, first serve, the last come, first serve. This may be zero, the service in random order. This may be priority queue, priority discipline. Priority may be primitive, non-primitive. So the fourth letter will represent the discipline of the queuing model. And the fifth one is E. E is the capacity of the queue. Capacity of the queue means how many persons will be accommodated in this queuing system. Means how many, for example, 5 customers, then capacity of the queue will be 5. 10 customers, then the capacity will be 10. Means what is the queue size? Queue size is representing the capacity of the queuing system. And this may be either finite or infinite. So this may be finite or infinite. And F is the last. F is the last. F is what? F is source population, or this is also known as calling population. Source population or calling population means the place or the destination from where the customers are expected to stream out, to come out from that area, that geographical area, to join the queue for the service. So this may also be finite or infinite. For example, if it is restricted, any doctor is restricted, but in particular street or particular place, and he is sitting in particular village, then you can say that doctor has the calling population that village. I mean, if village has 200 families or 200 total population, then size of the calling population is finite. That is the 200. So here the size or source population is finite. Then we have to mention here 100 or 200 or capital M or whatever number we can represent by that number. So, but if somebody is, suppose that hospital is, that institution is John Hopkins in US, this is the whole world is moving towards that. So that population seems to be very, very large, and we can say infinite. Infinity means very, very large here. So I would like to tell you the primary development of this notation. There are how many letters here, characters here? There are 6 characters involved or entered into this notation. Out of these 6 letters which are entered into this notation, the 3 A, B, and C, this combination of the letters is suggested by Kendall, and D and E, D and E. So this is the primary development of the notation, you can say. Later, D and E. So first it was in the beginning, it was only A, B, and C, like this. Means if it was a rival Markovian, then M, and if it was Markovian again, the service, then another M, and then if server is 1, then 1. So this was M1 model. So in the beginning, this was the representation of the queuing model MM1. But later the A.M. Lee has suggested, no, this is not sufficient. This is insufficient. This representation or notation is insufficient. This must be added. This must be extended by adding some more notations. And therefore, he added this notation DE. D means the discipline. E means the capacity of the queue size. But he was silent about the source. He did not discuss the source population or calling population. The Taha, he was none other than Taha, Professor Hamdi A. Taha, who added the letter, this notation F, and in this way, this notation has got 6 letters. He found important that the F is also very important, source population or the calling population. So in this way, if suppose, for example, the arrival is Poisson, so 1. If service is Poisson, then another M. And if server is 2, then this is 2. If discipline is P4, first come and the first serve, P4. So discipline is P4. And if capacity of the queuing system is infinity, so it is infinity. If source population is infinity, very large, then infinity. So this is a way of presenting the queuing model, expressing the queuing model in particular symbol or particular notations. One point is very important here. If you look at D, E, F are not specified. Not specified means these are later 3 letters. Later 3 letters. Later means in the beginning there were only 3 letters, A, B, C. So suppose these are not mentioned anywhere or somewhere, something is written like this is M. We are going to discuss queuing model M. M5. Suppose we are going to discuss the MM5, means the Markovian arrival is Markovian, the service is Markovian, number of servers is 5. So, but we have not clarified that what is the D, what is the E, what is the F. It means that if it is not specified, then it is understood, it is assumed that the discipline is first come, first serve, or FIFO. First come, first serve, or FIFO. It is understood. If it is not specified, then understood is this one. If it is not specified that it is finite, then it is always infinite. If it is not calling population is specified, then it is infinite. So that giving model is this one. And in most of cases, these three things are not specified. If you look at, it is simply written MM1. What does it mean? That three things are not specified. So it is assumed that discipline is there, first come, first served, and source population is infinity, and capacity of the system is infinity. So look at here the structure, architecture of the queuing model. This is the architecture of the one queuing model. The arrival is here Poisson, and the service is here Poisson, and there are three servers. You will find three servers, S1, S2, and S3. So after receiving this channel at this channel or station, the servers are divided in three rows, and they have joined three servers. Their capacity is supposed to be same, mu and mu, service rate and mu. They are identical servers. When servers are arranged in parallel, it means that they are identically of the same capacity. Their service rate is same unless and until it is categorized or it is mentioned that service rate is going to be changed. We will discuss such models also at appropriate point of time, that how this mu can also change. So here you simply look at PP3, P4, infinity, infinity. So this model is infinity, infinity, but P is not written. P means Poisson. P means Poisson. But I told you there is also very interesting aspect of this. P is not written, P is not given as a notation. In the notation, only M is given. M is given. Markovian, Markovian. So this is the Poisson. This is also very interesting. You must think for the discussion. I will discuss it at the time when we are going to discuss the individual models, queuing models. But you should keep in your mind and keep on searching why this happens in this way. Sometimes at different places we find this way of representation. You will find in some literature other than Taha. Taha is given this whatever the way we have written here. But in some of literatures you will find this kind of notations. M, 3, no problem. Here is this capacity of the system. Here is the source population is this one, and discipline is put at last. And in this way, this is also a way of representing, and some of the literature also mentioned this one. But Taha has expressed in his book that if Taha has searched this one, then discipline was searched by the AML. Taha has searched only the last one, that is the source population, size of the source population. So source population is the sixth one, that is the F. So F should not be here as a discipline. So in this way, but people do not know the history, people do not know the basic developments of the queuing model. They start writing whatever they have seen in any literature. They do not want to go to the root of the development of the notations, and they simply start writing. So in this way, you can look at another example here. A is M, B is M, C is 1, D is V4, E is 15, and F is 100. So M, 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 1, and V4, 15, and 100. This Q model also can be represented with this kind of notations. So it is finite and it is finite. And if you want to put this one outside, I mean, by the another literature, they do not follow the basic structure of the notation given by Lee and Taha, and also the Kendall, then you can write this LIFO is at last. So in this way, we can represent the queuing models as you will see in the literature that MD1 means the arrival is Markovian and service is deterministic, means that is fixed. There is no any concept of the probability which is entered into the service process. And this is the MG1. This is Markovian. Arrival is Markovian. Service is general service distribution. General service distribution means it may be any kind of distribution. This may be normal, this may be Poisson, this may be any kind of distributions we can talk about. So this is general way of writing and representing the queuing model. Similarly, the GG2 general arrival, general service, and number of server is 2. So this is also a way of writing the notations suggested by the Kendall and others. So you look at here, D, E, F notations are understood as infinity, infinity, and FIFO. Understood infinity, infinity, and FIFO, because here not mentioned the 3 letters. Now we come to the another important aspect of the queuing model, that is the assumptions. While developing the queuing models, we must know this point, that what are the basic assumptions which we must follow, or any users, any readers, any person who is going to make the application or who is going to conduct the research, we must understand this set of assumptions which are used while developing the queuing models. The first one is that there should not be any balking and reneging. If you are discussing any model, unless and until it is mentioned that we are going to study the reneging, the behavior of reneging or the behavior of this barking, we cannot accommodate this one in the model. Model is supposed to be very simple and it is not allowed. So this is first assumption. And the second assumption is what? Unless and until it is mentioned that we are going to study the transient state, means we are going to discuss the transient, means warm-up state. This is known as warm-up state. A stable state is different, that is the steady state. So unless and until the warm-up state is mentioned, that we are going to study the warm-up state or the transient state, it is assumed that the service channel or the service station is going to operate under the steady state. So always keep in mind that we are going to study this very model or develop this very model under the steady state. So recently what models we discussed, MM1, it is under the steady state because none other things, no any no any other state is mentioned that we are going to study the MM1 model under the transient state. So therefore the steady state is always assumed here that service is going to be under the steady state. And this third assumption is very important. Arrivals are independent, always. Arrivals as well as the inter-arrival times are independent. Means the arrival of one customer does not depend on the arrival of the another customer. And if this happens, then we cannot apply, the assumption of the exponential distribution, assumptions of the Poisson distribution. They must be independent, otherwise we cannot take the help of these distributions. If they cannot, then the study is not going to be analyzed, or this analytical and mathematical discussions are not possible. Service times are also independent. So you can say both arrivals as well as service, both times are independent. And next, fifth one is what? Any Q discipline. Until and unless any Q discipline is mentioned or given to us, it is first come, first out. We should not bother about this, that we are not given the discipline of the Q. It is understood that discipline is first in and first out. The next assumption is that giving capacity is infinite so far as it is not specified. It is not specified means so far as it is not mentioned here that, or is stated here that this is a finite. If it is mentioned here in the beginning that it is going to be finite, it's okay. Otherwise, it is assumption or it is assumed. Just now we have seen the case. It is assumed. Assumed means this is an assumption that it is infinite. Means capacity is infinite. Next one is giving source or calling population unless and until this is mentioned or provided, we can say that this is also infinite. So this calling population is also infinite. So in this way, these assumptions are very important. These notations are very important. And while developing these notations and assumptions, it is important for the user or the reader that we must keep in the mind while we are going to discuss or we are going to develop any queuing model, maybe for the research or maybe for the teaching or learning or research. So in this way, if you have any curiosity on this, you can ask a question. Otherwise, now